Hi everyone, welcome back to our asynchronous learning time today. And for our video lesson today, we're going to be talking about proofs. So you are going to need your notebook. We're going to be talking about 3 different kinds of proofs, and we're going to be actually writing some proofs for some conjectures. So if you don't have your notebook and a pencil, you'll want to pause the video and grab those things. And once you have those things, come on back and start the video again. The first thing I'm going to ask you to do is write down the title proofs. And we're going to talk about 3 different kinds of proofs. The first kind is a paragraph proof, which is you're just writing sentences. The second kind of proof is a 2-column proof, and it looks like a T-chart. And the third kind is a flow chart. So I'm going to show you what each of these looks like, and we're going to write proofs for these. So make sure you have down each of the 3 kinds of proofs. And the first kind we're going to talk about is a paragraph proof. It's just a logical explanation written as a paragraph. Once you have that down, I want you to draw the diagram of the 2 intersecting lines and then number the angles the way I have them numbered. You're starting over on the right-hand side 1 and counting around to 4 counterclockwise. And then we have a statement here that says the linear pair conjecture states that every linear pair adds up to 180 degrees. Using this conjecture and the diagram, write a logical argument explaining why angle 1 must be congruent to angle 3. So what this is saying, this part where it says explaining why, this part right here, this is the part that we prove. So usually in a proof, it'll say prove, and then it'll give you that statement, angle 1 is congruent to angle 3. This is our end result. That's where we want to go. And then there's usually something that's given to us. This one doesn't have anything given except the linear pair conjecture states that every linear pair adds up to 180. So we're going to be using linear pair conjecture or linear pair. Okay, so our first thing that we're going to write, our first statement, is we would say angle 1 and angle 2 add to be 180 degrees. So we're looking at angle 1 and angle 2. Remember, our goal is to prove that angle 1 is congruent to angle 3. So we want to prove these 2 vertical angles are congruent, but we've got to take a couple of steps to get there. So angle 1 plus angle 2 add to give us 180 degrees because they are a linear pair. Now our statement that we're writing, I'm going to underline that. That's the statement we're writing, and this is the reason why we know that, because they are a linear pair. Our second statement, or to continue with our paragraph proof, so then we could say angle 2 and angle 3 add up to 180 degrees. And we'd have for the same reason for that, because they also are a linear pair. And again, the statement that I made was angle 2 and angle 3 add to give me 180 degrees. Now, we have another step to go through. So I want to look at what do I have in common in these 2 statements, and I have an angle 2 in both of those. Angle 2 is the same in both, right? And so this seems kind of redundant, but it has to be said. Angle 2 is equal to angle 2 because of the reflexive property. We will occasionally be using properties that you used maybe in 6th or 7th grade. The reflexive property just tells us that 2 things that are the same are equal to each other. So angle 2 is equal to angle 2. And then the last piece that we have is then we would say therefore, because now we're ready to make our prove statement, therefore. And here's a symbol for therefore. It's a little triangle just made with dots. So therefore, angle 1 is congruent to angle 3, and that's the prove statement. Angle 1 is congruent to angle 3. So that's my statement I'm making by the addition property of equality. And all the addition property of equality is it's that property that we use like when we're solving an equation and we subtract or add something to both sides of the equation, right, to keep it balanced. So this would be like if we did angle 1 plus angle 2 is equal to angle 2 plus angle 3, and we subtract angle 2 from each side. So then we would have angle 1 is equal to angle 3. So that's the addition property of equality. It's just that step that you do when you're solving something algebraically. All right, let's look at our next type of proof that we have. Oh, goodness. There we go. The next, before we get to that, we're going to talk about converse statements. A converse statement, it's when we have an if-then statement and the if and the end parts switch places. So in this problem that we have, or this example here, we have if two angles are congruent, or sorry, if two angles are vertical angles, then the opposite angles are congruent. So if we were going to write the converse of this, we switch these. So this is the if part, and then here's the then, the opposite angles. So now we switch them. So we say, if the opposite angles are congruent, let's redo that. So the opposite angles are congruent, then the two angles are vertical angles. Now, this doesn't mean just because we can write a converse, it doesn't mean that it's always true. And so that's what we have to find out, if this statement is true. And if it's not true, then we have to find a counterexample. So when we're thinking about opposite angles, a counterexample for this could be a rectangle. And we have opposite angles this way, and they are congruent, but they are not vertical angles. So then we would say that this is a false statement, and our counterexample would be a rectangle. Okay, back to proofs. So now we're going to look at a two-column proof. And for the two-column proof, notice that we have a given statement, and this one says that angle 1 and 2 are a linear pair. And then our proof statement is to prove that angle 2 is congruent to angle 4. You need to draw a T-chart. On the left side, you write your statement, and on the right side, you write your reason. And it is very helpful if you number these as you go so you can see what goes with what. So when we're doing a proof and it gives us a given, that's like a freebie, and we always want to include that first. So the first thing we write is angle 1 and angle 2 are a linear pair. And my reason for that is my given. Don't forget that. One of the biggest mistakes I see students make is they forget to include the given. Okay, now, my second part. So remember, our goal is to prove angle 2 and 4 are congruent, right? And so this is very similar to the first one that we did. It's just the numbers are in a different order. If you didn't draw this figure, these intersecting lines, do that again so you have this down. And they're numbered differently this time. The 1 is still starting in the same place, but they're going around clockwise this time. Okay, our second statement then is angle 1 and 2 equal 180 degrees. So angle 1 plus angle 2 equals 180 degrees. And we know that because it is a linear pair. And you can just do LP for linear pair. So I know angle 1 and 2. Remember, I'm going to angles 2 and 4. That's what I want. So now I want to do angle 1 and angle 4. So angle 1 plus angle 4 equals 180 degrees. The reason for that is also because it is a linear pair. Now I'm going to write this as if I were solving this algebraically. So I've got what I have in common here. I've got angle 1 and angle 1 here, and it's all equal to 180. So that means I can say angle 1 plus angle 2 is equal to angle 1 plus angle 4. And this is substitution. It just means that I substituted in angle 1 plus angle 4 for this 180 right here. Just like when we're solving systems of equations and you use substitution. So similar to that. And then part 5. So now if I were to subtract angle 1 from each side, I would be left with angle 2. And we would say congruent, because we don't have measure in front of, is congruent to angle 4. And my reason for this is addition, property of equality. And I'm okay with you abbreviating like property, and you'll see me do that throughout. All right, we have one more kind of proof to do, and this one is a flowchart proof. So make sure that you have the title flowchart proof. Make sure you have the given statement, angle A plus angle B is 180. Make sure you have the prove statement, angle A is congruent to angle D, and that you have the figure drawn of these two intersecting lines over here, and the angles are called A, B, C, and D here. Now with a flowchart proof, with this, the box, this right here is your statement. And your reason goes underneath it. So this would be your reason. So they don't always have a line underneath them. Sometimes they will, but that's where you put your reason, is right underneath it. Your statement goes in the box. And just like with the float or with the 2-column proof, we start with the given. So in the box, we write angle A plus angle B is equal to 180 degrees. And my reason is the given. Again, remember, you always want to use that given. Now we've got these arrows. So that means like this statement and this statement have to lead into this one. Like we can't get to this statement here without these two. They support this one. So angle A and angle B is 180 degrees. Remember, we're looking for A and D this way. Okay, so now we want to do B and D, because then now we've got A and D covered. So if we do angle B plus angle D is equal to 180 degrees. Our reason that we know that is because it is a linear pair, or you could say linear pair conjecture. So that's what that tells us, is that it equals 180 degrees. If I know that those are 180 degrees, now I can say, well, they're both 180, so that means they have to be equal to each other. So angle A plus angle B has to be equal to angle B plus angle D. And the reason for this would be substitution. If we were solving this algebraically, we would subtract angle B from each side, and we would have angle A is congruent to angle D, and our reason for this would be addition, property of equality. So those are the 3 kinds of proofs. We have paragraph proofs, 2-column proofs, and flowchart proofs. And I want you to think about, just from the little bit that we've done right now, which kind of proof stands out to you? Which one do you maybe identify more with, or feels more natural for you in writing a proof? Think about that and come with that answer to our next live class. And when we meet the next time, we will be doing some proofs together in small groups. So I hope you are having a great day.